Okay, in the first section, we learned that if we have parallel lines, if the lines are parallel, and little arrows on the lines means they're parallel, that alternate interior angles are congruent, corresponding angles are congruent, alternate exterior angles are congruent, and same side interior angles are supplementary. So supplementary, congruent, 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 congruent. Okay? All right? Now, in this next section, just takes everything in reverse. Okay? So, if we know we have congruent corresponding angles, then it makes the lines parallel. If we know we have congruent alternate interior angles, then we know it makes the lines parallel. So we're just going in the opposite order. We're looking at the angles first and saying whether the lines are parallel or not. Okay. We can see that these are not parallel. Okay. So what do we know that this angle cannot be? There's one measurement of that angle that it cannot be, because they're same side interior angles. So it can't be how many degrees? No. What's a same side interior angles are supposed to be supplementary, right? But since these are not parallel, it cannot be 60. It cannot be 60 degrees. Because if it would be 60 degrees, that would make parallel lines here. But if we know they are not parallel, we know that this is not 60 degrees. All right. So, the converse theorems. If we have corresponding angles congruent, then we have parallel lines. Okay? You already know this, so you probably don't have to write this down too much because you already know corresponding angles. And all I'm worried about is corresponding angles part of it. I'm not worried whether it's a converse or whatever so much. Okay? It might come up as a converse on a quiz or test, but no, okay, I see corresponding angles. If we're going parallel lines, then it's converse. Okay? If we have alternate interior angles congruent, then lines are parallel. Okay? And then, so they say, well, let's make up a flow proof of this. Now, back in the 1980s, a long time ago when I went to school, we did computer programming. A little different than what you do computer programming now, but fairly similar. But we had to write out flow charts of what we were doing. This led to this, which led to this. That's a flow chart. One thing leads to another, leads to another, leads to another. So, in a flow proof, arrows show the logical connections between statements. That is your last vocab word of the chapter. So write that down, please. Arrows show logical connections between statements. Like I said, that's your 8th and final vocab word of this chapter. But we'll wait to take the vocab quiz until basically the day we take the test. Okay, let's look at a flow proof now. We're given that angles 1 and 2 are congruent. 1 and 2 are alternate interior angles, they're congruent. We know 1 is congruent to 3 because it's a vertical angle. So we're given on 1 is 2 congruent. 1 and 3 are congruent because they're vertical angles, something that we've proven earlier. And then that leads to, with the transitive property, since 1 is congruent to 2 and 1 is congruent to 3, then 2 is congruent to 3. Transitive property, 2 is congruent to 3. And we already know that if these are congruent, okay, they are corresponding angles. And if corresponding angles are congruent, then we have parallel lines. Okay, so that was a foolproof join corresponding. Same side interior angles postulate says if these are supplementary, then we have to have parallel lines. Okay, so it's basically the same as what the first section was, except for now we're given the angles first, then we're figuring out the lines. Now they add on to it just a little bit, so we'll get to that. If 3 is congruent to 7, are the lines parallel, yes or no? Yes, because 3 and 7 are what types of angles? Corresponding. If 3 is congruent to 6, are these parallel? Yes, they are, because they're what types of angles? Alternate interior. Alternate interior. Now, the next one says, if 2 lines are parallel to a third line, then all 3 lines are parallel to each other. Okay? So if this is parallel to this and this is parallel to this, then all 3 lines are parallel to each other. Okay? It's like the transitive property. If A is congruent to B and B is congruent to C, then A is congruent to C. So it's basically the transitive property of parallel lines. If A is parallel to B and B is parallel to C, then A is parallel to C, so that all 3 are parallel to each other. Okay? Okay. Same thing goes for perpendicular lines. If A is perpendicular to C and B is perpendicular to C, then A and B are parallel to each other. So if 2 lines are both perpendicular to the same transversal, then those 2 lines must be parallel to each other. So, Bailey's building a gate. We know that this board here and this board here have to be parallel to each other because A is our transversal, and if A and V are perpendicular, and A and W are perpendicular, then V and W must be parallel. Okay, V and W must be parallel. So, to be a parallel line, if corresponding angles are congruent, then they're parallel. If alternate interior angles are congruent, then they're parallel. If alternate exterior angles are congruent, then they're parallel. If same side interior angles are supplementary, then they're parallel. That's ways of proving lines parallel.